Welcome to The Explainer. Today we're diving into what I like to call the archaeological dig of Cambridge Computer Science exam strategy. We are going to dig incredibly deep into the 9618 syllabus to uncover the hidden clues buried right there in the questions. Layer by layer, we are going to reveal the anatomy of a perfect answer, specifically focusing on the notoriously tricky topic of exception handling. Now, I want you to picture two types of students sitting in that exam hall. We've got Alex on one side and Sam on the other. Alex has memorized the entire textbook. When faced with a question, Alex just completely overloads the page with raw computer science facts, writing a massive wall of text, but providing absolutely no real analysis. Then you've got Sam. Sam is racing against the clock, rushing through the paper, completely missing the specific command word requirements of the prompt, and just throwing down half-finished thoughts. Sound familiar? By the end of our time together today, you are going to have the exact blueprint for what the principal examiner is actually looking for, so you don't make Alex or Sam's mistakes. We are going to decode the methodology that completely separates average responses from those elite top-tier grades.
So, let's ask the big question. Why do most students lose incredibly easy marks on exception handling? It's a painful truth, but it is almost never because they don't understand the underlying code. When you look at Alex and Sam's flawed answers side by side, covered in red pen marks, the issue isn't their technical knowledge. The issue is exam technique. Today, we are going to explore exactly what the principal examiner is hunting for in your answers across the Cambridge syllabuses, whether you're looking at 0417, 0478, 0983, 0984, 2210, or especially 9618. It's all about how you approach the problem, how you structure your critical thinking, and exactly how you communicate your logical process on that exam paper. You see, the examiner isn't just looking for a correct final output. They are evaluating your entire problem-solving architecture.
Look at this absolutely brilliant insight directly from the examiner alerts. Even if your final answer is wrong, method marks can save you. I cannot overstate how important this is. This is the foundational secret for the methodology we are about to unpack. So many candidates literally freeze up when their final algorithm doesn't perfectly resolve. They panic, they cross everything out, completely forgetting that the Cambridge examination system highly rewards the process. If you show the breadcrumbs of your logic, you get points. We're going to show you how to capture those process marks, those beautiful method marks, every single time you put pen to paper, regardless of whether your final line of code is completely bug-free.
Okay, here is our strategic roadmap for mastering this topic layer by layer. First, we'll look at core principles and connections. Second, the method mark strategy. Third, the top 3 examiner warnings. And finally, critical and comparative analysis. Let's get moving.
Section 1, Core Principles and Connections. Let's break down the theoretical architecture of exception handling.
The syllabus explicitly emphasizes that top-performing students don't just blindly memorize definitions, they dynamically adapt their knowledge to totally new scenarios. This is what we call transferable understanding. The exam will almost certainly present you with a complex programming scenario you have never, ever seen before. It's an alien context. Transferable understanding means you can look at that strange scenario, identify exactly where an exception might pop up, like a division by zero error, a Stack Overflow, or a file not found error, and logically apply the core principles to manage it gracefully. And listen, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, jumping back in, dealing with these alien contexts requires a framework, specifically the PEAL framework. Point, evidence, explanation, link. We'll be applying this to everything we do today.
To really secure those top marks, you need to satisfy 3 distinct cognitive domains targeted by the specific computer science assessment objectives. First, knowledge and understanding. That is your basic grasp of what an exception actually is. Second, application. Your ability to actually write or trace the specific exception handling code. And third, analysis, which is where you break down complex data, extract the vital information, and draw evidence-based conclusions about why a specific exception handling routine is necessary in that given system. So when you're looking at a question, I want you to play a quick game with yourself. Ask, which cognitive domain is this command word targeting? Are they asking me to just state something, apply something, or analyze something? Knowing that completely changes how you structure your PEAL paragraph.
Now, what's really fascinating about this next slide is that it reveals the ultimate secret to high marks: cross-topic connections.
The principal examiner reports consistently highlight that candidates who reference other areas of the computer science syllabus achieve significantly higher marks. It's like a cheat code. If you can explain how an exception in a program relates directly to data integrity in a database, or how it severely impacts network security protocols, or how it ties into batch file processing, you are demonstrating the exact connected conceptual understanding the examiners are desperately looking for. You're showing them you understand the entire ecosystem, not just an isolated line of code.
Section 2. The Method Mark Strategy. Let's see how we build this into a truly actionable technical exam strategy.
This standardized 5-step sequence is your procedural framework for systematically processing any complex problem. Think of it as the computer science success blueprint. Remember our students Alex and Sam? Let's conceptually rewrite their flawed answers right now. I'm going to put 60 seconds on the clock in my head. When you face a tough exception handling question, don't just immediately start scribbling code like Sam does. Stop. First, decode the command word and identify the key elements of the problem. Second, apply the relevant theoretical principles using that Peel framework. Third, execute your analysis with absolute clear working. Fourth, verify your results against the edge cases. And finally, present it in the exact format requested by the command word. By forcing yourself through this transformation pipeline, you are practically guaranteeing that you pick up marks at every single stage of the evaluation process.
Look at this comparison. Final result versus clear working analysis. Imagine seeing those brutal red pen marks on your paper miraculously transforming into green check marks. How does that happen? Because the crucial point is that executing your analysis with highly visible working is where the method marks are awarded, even if the final result ultimately fails. Let's say you miscalculate a binary representation or you make a silly syntax error in your final code block. If the examiner can see your clear working, if they can clearly see you successfully identified the exact exception trigger and attempted the correct structural solution, they can and will award you method marks. Never, ever erase your thought process. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump into our interactive workshop for Act 4. These 4 critical steps represent the practical application of your programming skills within exception handling. Imagine I've just put a massive, complex computer science data source on the screen in front of you. I'm giving you a 60-second visual countdown timer for Challenge 1, the data scan. When you are developing your answer under pressure, you need to quickly show that you can design an algorithm that actively anticipates errors, implement a robust solution that catches those specific errors, explicitly explain how you would test thoroughly to ensure the exception is actually caught, and finally, evaluate the real-world performance impact of your error handling code on the system. You have to be able to extract that core trend from the data source almost instantly. Section 3. Top 3 Examiner Warnings. We've reached the most critical part of the explainer. We are now moving into Challenge 2, Find the Flaw. There are exactly 3 major pitfalls that cause students to needlessly lose marks year after year. I'm going to explain them, and I want you to actively think about your own past paper answers to see which of these traps you fall into the most. Lock these 3 examiner warnings into your memory. First up, examiners constantly report that students confuse cause and effect. You need to clearly distinguish between what actually caused the error and the resulting exception that was thrown. Second, students constantly forget to check boundary conditions in edge cases. Exceptions absolutely love to hide at the extreme limits of your datasets. And third, answers are often generic and not specific to the given context. Remember how Sam rushed? That's what happens when you rush. You might even want to create a quick mnemonic using the first letters of these key terms: cause, boundary, context, or CBC, to anchor them in your mind when you're sitting in the exam hall.
It is absolutely vital that your answers remain highly specific to the context provided in the question. Writing down a perfectly memorized textbook definition of an exception handler, like Alex loves to do, will get you minimal marks if you don't explicitly connect it to the specific scenario. If the question is about a temperature sensor failing in an industrial cooling system, your answer must talk about the temperature sensor and the cooling system, not just some generic variable error. Okay, Challenge 3, Speed Writing. Imagine you have 30 seconds on the clock right now. Could you write one perfect Peel paragraph contextualizing a sensor failure? Point, state the failure. Evidence, reference the sensor data. Explanation, Explain the exception handling logic. Link. Connect it back to system safety. That is how you win.
Section 4. Critical and Comparative Analysis. Let's level up to the final tier. We are now building your ultimate cheat sheet, establishing the final system. Rule 1 of our 3 rules for top marks is command word decoding. When conducting comparative analysis, because a command word asks you to compare 2 different ways to handle an exception, you must identify both similarities and differences. But you can't just list them. You have to use comparative connectives like whereas, however, or similarly. You must support each point with solid evidence before drawing any conclusions about their relative importance.
Rule 2 is the strict application of the Peel framework to evaluation criteria. This brilliantly illustrates the 4 exact criteria required by examiners when evaluating algorithm quality. If you are asked to evaluate an approach, you must discuss its time complexity, how fast does it execute, its space complexity, how much memory is it eating up, how does it handle those tricky edge cases we warned you about, and finally, its overall effect on system performance. If you hit these 4 specific points using the Peel structure, your evaluation paragraph will literally be bulletproof.
Rule 3 is your time management matrix. Follow this 5-step exam strategy to tackle any high-level question rapidly and flawlessly. Deconstruct the prompt so you know exactly what is being asked. Extract the relevant data. Select your analytical framework. Execute your answer with incredibly clear notation. And present it all using the correct, precise computer science terminology. If you apply this matrix, you won't end up rushing out of time like Sam.
So here is our animated summary of the entire system. Master the procedural method. Integrate and connect your concepts across the whole syllabus. And above all, always show you're working. These are the ultimate takeaways from the principal examiners. Now listen closely, because the proof is in the results. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
As you sit down to practice past papers this week, I want you to think really critically about this final question. How can you link these exception handling concepts to other areas of the syllabus, like databases or network protocols, to secure those top-tier marks? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer video with a study partner. Ace the Exams, your Cambridge success starts here.